All right. So I'm hoping that these first couple pages were pretty easy for you guys. It was just, the rule is just, sometimes writing down a rule at the top helpful. If we have x to the 1 over y, or we'll say, how about z over y? It becomes x to the y root to the z. Okay? So whatever on top is what it's raised to, what power it's raised to, and whatever on the bottom is what the root is. Okay? That's kind of, some of you do well with examples, some of you do better with like a formula. Okay?
Yeah, I need a formula.
So our examples here is if it's 7 to the 1/2, that's the square root of 7 to the 1. That little 2 right there you don't need. I just put it there to kind of make sure you kind of understand my example. Okay? So now we're going to I'm just going to read these off and then I'll go over which ones you want on this first page before we move on. Number 2 is the third root of 4 to the 4th. 3 is the third root of 2 to the 5th. 4 is the third root of 7 to the 4th. Please don't talk right now. Please don't talk right now. Number 5 is the square root of 6 to the 3rd. The square root of 6 to the 3rd. Number 6 is the 6th root of 2. Number 7 is 7 to the 3/2. 7 to the 3/2. Number 8 is 2 to the 1/6. 2 to the 1/6. Number 9 is 2 to the 5/4. 2 to the 5/4. Number 10 is 5 to the 5/4. 5 to the 5/4. Number 11 is 2 to the 1/3. 2 to the 1/3. And number 12 is 10 to the 1/6.
All right. How did you get 7?
Number 7?
Yeah.
Okay. Yeah, I'm for partial credit. Yeah. Okay. Number 7 is, it's being square rooted, right? So I know that's like a 2. So that's why that 2 goes on the bottom, 3 goes on the top.
Like there's not a number.
When there's not a number, it's square root. Yeah, it's like that 2.
So a 2 will go on.
So if a number is
right.
outside of that box, it is square root.
Right, see how this is like there's a 6 right there
So
by
that
the
6 goes
root?
on
That's
the
why the
bottom.
6 goes on the bottom.
But if there
All right,
wasn't a number,
I'm understanding.
if there wasn't
Keep
a
going.
number there, 2 would go on the bottom.
Yep.
And for number 3, how did you earn? Was it number 3? No.
Number 3 don't got a square root.
Last 2.
What about number 9?
Which number? I'm sorry.
9. You see how 4 is square rooted, and that's why it's on the bottom?
I'm sorry, I can't hear. Which one?
9.
9. Number 9.
Number 4?
Yeah.
4 got the square root of number 4, so that's why it's on the bottom.
Yep, 4 is on the
5
bottom.
is square root on the outside, so that's why it's on the top.
Yep. Guys,
I'm getting it.
is there other questions?
Yeah, for number 5, why is it just 6 square root of 3?
Yeah, it's square root 6 to the 3rd because you don't need a little 2. You can put the 2 there, but you don't need to.
Okay, I didn't know if that
Okay.
was wrong or not.
So if you put a 2 here, I wouldn't mark it wrong on your test tomorrow. But you don't need to, and I want you to be able to see it both ways so you don't if you see this, you know what to do to go both ways, right? Okay. Next page.
Yeah.
Okay.
Can you write the formulas down or something?
Yeah. Thank you. Okay, so we're looking at number 13. We've got the 4th root of 5x to the negative 5. Okay. Number 14 is the square root of 5x to the negative 1. Number 15 is the square root of 10n to the 3rd. And 16 is the 5th root of a to the 6th.
I just added the 2.
Wait.
I put 1a, is that okay?
Yeah, if you, in the inside, 1a.
Yeah.
Yeah, that's fine.
Okay.
Okay. Number 19.
No. 15.
Hold on, let me go over all this on the page and then we'll go back. M is to the 3/4.
Yeah, I got that part. That part.
20 is 6x to the 4/3. 21 is v to the 1/4.
Yep.
22 is 6p to the 1/2. Please don't talk right now.
Yep, got that.
Jalen, I really appreciate it, but the rest of the class is trying to do it too, so if you could do that in your head instead of out loud, that would be really great. 3a to the 4/3. 3a to the 4/3. 24 is 3k to the -5. It's just because that 5 is on the bottom. It's like a fraction. Number 1 here is 100. Number 2, did I do that right? Hold on.
X equals 100. Oh, I got that right.
X equals 100 for that one. Number 2 is 1,000. Number 2 is 1,000. Don't ruin his mojo. He thought he was doing great.
Oh, okay, we're going to
Number 3 is 13. Number 3 is 13. And number 4 is 38. Number 4 is 38. Okay. Any of these you want to go over? Jalen, was there one?
Yep, go.
Okay. Number 15?
16. No,
16?
15.
15? Okay. So see how that's a little 2 right there? That means it's to the square root. And then that 3 on top means it's raised to the 3rd power.
Yeah.
Right. You can put a 2. If you put a 2 right there, it would not mark it wrong. That's fine.
All right, see number 13. If
Yeah.
you had a 2 right there, we just square root it.
Yeah.
Like you did on that one.
Yeah.
So whenever it's a 2 at the bottom.
Yeah, see how there's a 2 here? That's why it's just square rooted. Yeah.
All right.
Any others on this page before we move to the next one? The bottom ones?
Yeah.
Okay.
I get how you got number 1.
Okay, if we look at number 2. Okay. Okay. If we look at number 2, we'll just do it again. We've got 10 equals the square root of m over 10. Okay? What do we do to get rid of a square root? We square it. So we square both sides.
Okay. Yeah.
10 times 10 is 100, right? Equals m over 10.
So.
Now, how do we get that 10 out of the bottom? What's the opposite of division?
Multiplication.
100 times 10.
And 100 times 10 is 1,000.
Oh, I was just guessing. That was right. 100 times 10? Wow.
Questions?
I just started guessing.
Okay, so a lot of you, remember that if you have a square root, you want to square it to get rid of it, and you'll be okay. All right.
Yeah, those 3 just.
Okay. Let's move to the next page. Number 13 is 9/2. 14 is 0. 15 is -7/2. 16 is -7 to the square root of 5. I don't know why I'm saying 5/2. -7 square root 5. 16 is 4 square root 5. Sorry. 17 is 7 square root 2. 18 is -3 square root 2 minus 2 square root 6. 5 is x to the 3rd power square root 5. X 3rd root 5x squared minus x to the 3rd power 2 times the 3rd root 5x squared.
Yeah, I got a more simplified.
Okay, I might have, we'll look at that one again. 6, I got -5xy to the 1/3 power. 7, I got 5y squared to the 3rd root 6y. Number 1 here at the bottom, I got 3x to the 3rd plus 6x. 2, I got 4x to the 4th. 3, I got x to the 4th over 2x minus 1. And 4, I got 81x to the 4th, y to the 4th. Okay, so should we go to 5? Let's do 5 together. Maybe I made a mistake there. Okay, let's try this again. So we've got the 3rd root 5x to the 5th minus x times the third root 40x squared. Okay, so we need underneath the square root signs to match. In other order, just subtract them. So the first thing I notice right here is we can take out 3 of these x's because it's to the third root. So if we put 1x on the outside, you know, like 1, 2, 3, 4, 5. How many groups of 3 do I have? Oh, I have 1 group of 3, so I can take that out on the outside. So I have 5x squared in the inside still. Okay? Now I'm looking over here, and I've got 40. What 2 numbers multiply to give me 40? Where I can take a third root out. 10, there's nothing times 3 times itself. You know, like 3 times 3 times 3 is 27. We need something where you times the same thing but 3 times, and it can give you 40.
How many of these are on the test?
Like 2, maybe 1.
Okay.
So 40 is 8 and 5. Okay? 8 is 2 times 2 times 2, right? So we can have x to the third, not x to the third, x to the third root 5x squared minus, we're going to take out 2x to the third root 5x squared. See how these inside match? Now x minus 2x is just negative x. Here.
Where does the 2x come from?
Because 2 times 2 times 2 is 8, so we took the 2 and put it out there in front of the x. Okay? Giving us 5x squared. So that's my final answer. So I just didn't finish the problem. Yes, Jalen?
Never mind.
Okay. Any other questions on this page?
Hold on. Go up to 14.
14.
I think it was 14.
Do you see how this is negative 3 square root 6 plus 3 square root 6? The square roots are the same. So we just do what's in the front. So 3 minus 3 is 0, right?
Oh, so if the square roots are the same, you do what's in the front.
Yeah.
And if they're different, then...
Then you try to make them like number 16. See, this is 45 and this is 5.
Yeah.
Well, what times 5 gives me 45? Oh, that's 9. 9's a perfect square. The square root of 9 is 3. 2 times 3 is 6, so we get 6 square root 5 minus 2 square root 5. These two right here, 6 square root 5 and 2 square root 45, those are the same. It's just more simplified to get it to be the 5. And then 6 minus 5 gives me 4.
Okay, and can I see
15, yep. Again, same thing, 20 becomes 5 and 4. 4 gives me 2. 2 times negative 3 is negative 6. So negative 6 minus 1 gives me negative 7. Then you have that square root 5 at the end. Any other questions on this page, guys, before we move to the next? Okay, let's move to the next page. You got it, June? Okay, these are all of our function notation where we stick things in, where we've got 2 functions and we're putting them together, or we're combining them in some way. This one we're going to do f of x, which is x minus 1, minus g of x, which is 2x squared minus 3. Okay? All you're going to do is distribute the negative and then combine like terms, giving us negative 2x squared plus x plus 2. This other part, do you see how these say the same thing right there? This says x, so we left it as x. This says 3, so all I'm going to do is take this right down here that I've solved and replace 3 for where x is, giving me negative 13. Okay? So then 6a gives me 2x squared plus x minus 4. B gives me 2. 7 gives me 8x to the third minus 2x squared minus 12x plus 3. And b gives me 435. And then 8 gives me, we did this one, it gives me 2x plus 4 over x squared minus 2. And b gives me 4. Okay, is there any on this page that you want me to go over in more detail?
Can you just show me 6, please?
Just get 2. And I recommend you just sticking this in your calculator. See how I put the parentheses around where the x went? If you type it into your calculator just like this, it comes up with the answer.
Okay, you show me 6a.
6a, yeah. 2x squared plus x minus 4.
I got it.
See how this is negative 3 and this is negative 1? That's how I got negative 4.
Oh, I didn't have a negative one. I don't know why I didn't. Okay.
Okay. All right. Next page. Remember we showed these all could be two ways. You can just stick in the inner part into the first equation, and then whatever answer you get, stick it into the next equation, or you could try to put them all together at once like I do. 9 is negative 19. 10 is negative 19. 11 is negative 46. 12 is negative 25. 13 is negative 9. And 14 gives me 23. Would you open the door, please? Hold on. Let's do the bottom. Number 5. Shh. I'm not sure why you're talking right now. Shh. This is not difficult. Shh. Number 5 is no, they are not. Please stop talking. I'm in the middle of recording this. We're working on this right now. Number 5 is no, it's not an inverse. 6 is no, it's not an inverse. Shh. 7 is no, it's not an inverse. And 8 is yes, it is an inverse. Okay. So any of these that you would like to look at?
Yeah, number 10, I got 17.
Number 10. So let's look at number 10. So a lot of you guys like it this other way that I've done it. So it's negative 7 plus 1. So negative 7 plus 1 gives me negative 6, right? And then I take negative 6 and put it in for f of x. So I get 3 times negative 6 minus 1. 3 times negative 6 is negative 18. Negative 18 minus 1 is negative 19. That's my final answer.
I have that. I can still have it.
Okay.
And, what did you get for 11?
Negative 46. Okay.
Go.
Yep. So if you go negative 24 plus 1, you get negative 23, right? Okay. Then if you take negative 23 times 2, you get negative 46.
That's all?
Yep. Yep. Okay. Any from the bottom of this?
Yeah.
Okay. These are all...
I struggle with anything.
Okay, let's do the one that actually works. Let's do 8. Okay. So with inverses, remember, you're just switching x and y. So you're going x equals negative 2 over y minus 1. So the first thing I'm going to do is add 1 to both sides. Okay. I get x plus 1 equals negative 2 over y. This is where I lose a lot of people because that y is on the bottom.
Right.
Well, let's get rid of the y on the bottom. So we're going to multiply both sides by y, right? And I get y times x plus 1 equals negative 2. Well, I want y by itself, so what is y doing to x plus 1? It's being, so what am I going to do? What's the opposite of multiplication?
Division.
Divide, so I can take all of it together. And so y equals negative 2 over x plus 1. And that works. That's yes, that's true. Did it like really mess you up when I multiplied by y and then I went back and I multiplied right afterwards? Yeah.
So you multiply by y.
So another way to
I
think
just
about
added
this.
the y on the bottom.
So if you hate what I just did, you can think of it this way instead. This is just another way because some of you look really confused. If you hate that I'm giving you two ways, sorry, but I just feel. You could think of it as cross multiplying. So you get negative 2 equals y times x plus 1, if that is easier to kind of understand. And then you divide by x plus 1.
What happened to the 1? The cross multiplication?
When you cross multiplied,
Oh.
1 times negative 2 is just
Okay.
negative 2.
Okay, and then. Okay.
Just remember, if you have something on the bottom, divide it. You know, like something on the bottom that's being divided, multiply it. If you have something to the third root, you're going to cube it. You know, opposite of these things, if we're, if they're to the third power, you have to cube root it to get rid of it. If they're being squared, you have to square root it to get rid of it. It's just opposites.
Can we do one that is not?
Yeah, let's see what we got on the back, because I think we have more inverses. Okay, if we look on the back, number 13 is 2x minus 18 over 7. 14 is x minus 3. 15 is negative x minus 3 or negative x plus 3, whichever way you want to say it. 16 is x over 4 equals y. We did 19. I thought we would do 20 together. But is there anything 13 through 16 that you want me to do?
Yeah, any of them.
Any of them? Okay. Let's look at an easy one, like 14. Okay? 14, we have x equals y plus 3. What do I do? Miss Murphy speaking. Sure, I was in a Okay, so we're just going to subtract 3 from each side. X minus 3 equals y, and I'm finished. It's the whole thing.
All she did was move the number over.
Right? You switch these, where x and y go, then move the number over. That's it. Okay?
This is
All right.
so much easier.
Jalen, you're being signed out, by the way, but do you want me to go over this one before you go?
Signed out.
Jalen Fisher is being signed out. Sorry.
Well,
There's 3
not the
J's.
graphs.
You want me to do a graph before?
Yeah.
You leave? Okay. All right. So, I highly recommend when you have a graph, it asks you to do, this is asking you to do 3 things. 1, graph this original problem. 2, find the inverse. 3, graph the inverse. So it's asking you to do 3 things. Okay, so the first thing we're going to do, I don't know what's going on with you guys. Okay, so we're going to graph this. So I'm going to type in negative x minus 5 over 3. And a graph shows up, right? That's a little bit hard to just copy right on there. So if I hit Control T, a table pops up. And like at negative 5, I'm at 0. At negative 2, I'm at negative 1. At 1, I'm at negative 2. At 4, I'm at negative 3. Okay? So here's my graph. All right? Now, I want to find the inverse of this problem. So I'm going to say x equals negative y minus 5 over 3. Okay? 3 is being divided, right? What's the opposite of division? Multiplication. So I get 3x equals negative y minus 5. What do I do next? Add 5. So 3x plus 5 equals negative y. Now what do I do to get rid of that negative? Divide everything by a negative. And I get negative 3x minus 5 equals y. And you can graph this, like this is a pretty straight linear problem. If you just want to plot negative 5 and then go up 3, 1, 2, 3 over negative 1. But you can also graph this in your graphing calculator, hit Control T, and you see the points too. So I have 3 things. I have the original graph, I have the inverse, and I have the inverse graph. I'd get full credit for this.
Yes, sir.
Okay. Questions, comments, concerns about this? No, the test is tomorrow. All right.